Okay, so guys, today we'll be looking at tutorial sheet 5, question 3, which says car 1 was sitting at rest when it was hit from the rear by car 2 of identical mass. Both cars had their brakes on and they skidded together 6 meters in the original direction of motion. If the stopping force is negative 0.7 times combined weight of the cars, okay, we have our coefficient of kinetic friction, which is 0.7. Find the approximate speed of car 2 just before the collision took place. So guys, like I said in the previous recorded video, like, you have to learn to picture the things that you have to learn to picture everything, every question, like you have to put it on paper. So we have they're saying this car 1 and car 2. So car 1 was hit by the rear by car 2. So upon these two cars colliding, they skidded together 6 meters, a distance of 6 meters. Okay, so we shall use the equation of conservation of linear momentum. So we have car 1 and car 2. So we know that m1, the initial velocity of m1, plus m2, which is car 2, with the initial velocity of car 2 is equals to, since they skidded together is a distance of 6 meters, so we'll combine the masses, and we know that the identical masses. This is the reason why we have 2m, because their masses are identical. And then we have the final velocity, which is the same because they were attached and skidded together. So we shall say okay, so we have to make, since the question requires us to find the speed of car 2 before the collision took place, so this is the initial speed of car 2 which we are looking for. So we know that the initial speed of car 1 was 0 because it was at rest, so this will go out because the initial velocity of car 1 is 0. 0 times the mass to be 0, so we'll remain with the mass of car 2 times the initial velocity of car 2, which is equals to 2m final velocity. So we shall have, we divide both sides by this m. By the way, this smaller 2 down here is just an indication of the mass for car 2. So we write our m here, and then we divide it this side or cancel out, so we shall remain with the initial velocity of car 2 is equals to 2 final velocity. This is our first equation. Remember, of course, this question has got 2 parts. So we've got the first part for collision, okay, then the second part for the moving of this 6 meters distance. So we've used we found the first equation, then we'll find the second equation using the work energy theorem. So we know that these cars, just after hitting each other, like they skidded together a distance of 6 meters. We know we've been given the coefficient of the kinetic friction here 0.7. okay, so we know that our formula is change in kinetic energy is equals to negative F times S. Okay, so negative F, this is basically the friction, of course. Then we can rewrite this as half m we're talking about the velocity, final velocity squared minus initial velocity squared, okay, which is equals to negative frictional force times the distance covered, which is s. Okay. So we should also put in mind that what we mean here is that the initial velocity of these cars, because this part, the part that we are solving for right now, is the point at which the cars got entangled, like they got together and then skidded together. So we're taking them as one thing. So meaning we have our, okay, let's say since we're looking for, let's say okay, our final velocity, we know that our final velocity here is 0 because it comes to rest, this whole thing, after it's skidded together. So our final velocity is 0 in this part. So we have 0 minus v squared is equals to negative fs. Okay, so which we can also rewrite as negative half mv initial velocity squared is equals to negative fs. Okay, so the thing here is that our initial velocity here, as in on this part, like from the time they got together, that's the final velocity of car 2, like the initial velocity of the cars moving together from the point at which they got together and moving together is this, it's the same as the final velocity of car 2, because that was at the point at which it hit the car 1 and changed its velocity. So we shall have, okay,